As described on the last slide, the process of rendering images and producing specific colors on a printer is different and more complicated than on displays. Halftone cells are very important to understanding how printers can render images made up of different colors. They're an invisible grid of cells that are filled with varying numbers of the fixed size printer dots that I talked about on the last slide. The cells are all the same size within an image, like pixels. Here's an illustration of the relationship between printer dots, and halftone cells. The printer dots filling a given halftone cell creates the appearance of a single dot of color. This is called a halftone dot. Halftone dots are the same as the concept of pixels, since they're both containers of smaller dots. But the major difference is that halftone dots can be different sizes. This is according to how many printer dots are filling each halftone cell. In the case of display pixels, there are always only 3 dots within each pixel. In the illustration, there are 7 printer dots filling the halftone cell, but there could be many more. Halftone cells are not limited to being composed of only 3 dots, as in the case of display pixels. When magnified, you would see halftone dots appearing at different sizes, depending on how many printer dots are used to create each one. What is the purpose of varying the size of the halftone dots, you might ask? Well, the size of the halftone dots varies to control the color tone of that dot. Larger dots for larger areas, smaller dots for lighter ones. We'll cover how the halftone dots convey color shortly. Here's another new term related to printer image rendering: screen frequency. Screen frequency is measured in lines per inch, which indicates the number of halftone lines or rows of halftone cells printed in an inch. The important thing here is that screen frequency is a little bit like printer dots per inch, except here we're talking about the size of the cells containing those printer dots. Screen frequency determines how small each halftone cell is, thus the amount of detail and smoothness of the printed image. Screen frequency is not a physical property of the printer. It's set in software, like image pixel density. However, there is a limit to how high screen frequency can go. It depends on how many dots per inch the printer can deliver. In other words, the printer dot density you learned about in the last slide. Here's an illustration of halftone dots. On the left is a magnification, and then on the right is what you actually see. You can see clearly the different sizes of the halftone dots and how they convey color tone.